I'm presenting about a new way we have for understanding Alzheimer's disease, about something called stress granules, where we've shown that we believe that stress granules are kind of one of the central parts of the development of the pathology of Alzheimer's disease, but heretofore have been unrecognized. And it's important because it lends itself towards therapy. There's a group of proteins that cause these stress complexes, as they call it. We call them stress granules. And these are called RNA binding proteins. Mutations in these RNA binding proteins are common causes of brain disease. And it turns out that the accumulations in the brain that cause Alzheimer's disease have lots of these RNA binding proteins in them, and they're kind of what I call a persistent pathological stress granule. So the idea is that we've heard about beta amyloid, and beta amyloid causes toxicity, and then the idea is that that tau, which is the other pathological component, contributes to stress granule formation. It's meant to be a transient response, but if you have a chronic illness like cardiovascular disease or diabetes or A-beta sitting around, it becomes persistent and pathological. The basis of the stress granule response is built around a physiological, normally reversible aggregation of these RNA binding proteins. They're designed to aggregate. That contrasts with our conventional view of Alzheimer's, where aggregation is a mistake, something that shouldn't happen. But actually, for these stress granules, it's meant to happen transiently. But when it becomes persistent, that becomes bad. But the flip side of it is, our bodies are designed to both induce the aggregation of these and to reverse and disperse the aggregates. And so what we're doing is we're trying to harness the system, the signaling pathways that come off of the ribosome to disperse the aggregates that are associated with these diseases. And what I'm showing here today is an example where we've already done this in amyotrophic lateral sclerosis, where these aggregates of TDP-43 we can disperse. And we hope to be able to do the same thing for Alzheimer's disease. Congress like this is useful for bringing people with differing ideas together, and to have mingling of people from various parts of the world. We all get stimulated by meeting with new people, meeting with new ideas. And so I think that there's a huge benefit for that.